So this is the beginning of chapter 11. This is simplifying rational expressions today. This is our last chapter of the year. We're going to get started straight away by talking about what a rational expression is. Remember, rational means you're dealing with a fraction, and since we're dealing with a rational fraction, now you're going to have algebra in this fraction. So you're going to have variables, you're going to have operation signs, and all this is going to be in the numerator and in the denominator. And these are going to have polynomials. Remember, polynomials look like you've got monomials, binomials, trinomials. All these things can be written inside of a fraction now. So when we see this, it's going to look like, let's give you some examples here. Let's see, 2x plus 4 over 7a minus 3b. These are not necessarily simplified, but these are rational expressions. This is a binomial over a binomial. You can see we have different variables on top and bottom, etc. We can also have a monomial over a monomial. We've seen these before. 3x squared y over 7xz to the third. You've got some variables in common. They don't have to have them in common. You would have to simplify those out if you needed to simplify them, but it's still a monomial over a monomial. Therefore, it makes it a rational expression. One you're going to see a lot of is going to involve quadratics. So when you have this, x squared plus 3x minus 4 is an example of a quadratic. We could put it over another quadratic. Let's see, 5x squared minus 2x plus 9. That is another rational expression. Excuse me. That happens to have a quadratic on top and a quadratic on bottom, or a trinomial on top and a trinomial on the bottom. Now, these rational expressions have something unique about them. They have what's called excluded values. There's a problem. When you have a fraction, something's going to be in fraction form, you cannot let the bottom of that fraction, the denominator, equal 0. Because of that, you have these values that will mess up your problem. They're called the excluded values. It's whatever number will make the bottom equal to 0. So remember why this is an issue. If you take a number and you try to divide it by 0, you will get what's called an undefined term. Because it is undefined, it does not work in our number system. Therefore, if you have something like 3 over x plus 1, we need to find the value that will make the bottom of this equal to 0. Now, we could do a formal equation and do all that, but guys, we're past that point. We just need to look at this and see what's the opposite of plus 1. Well, that would be negative 1. So we know that x cannot equal negative 1. If it did, this is what would happen. 3 over negative 1 plus 1, we're just replacing the x with the value that we said was the excluded value, and watch what happens. We get 3 over 0. That does not work. That would be undefined. Therefore, the x cannot equal negative 1 in this problem. That's called its excluded value. So we're going to use simplifying excluded values, and then we're going to combine those two concepts. Let's get started. Here we go. For the first one, you're only talking about doing excluded values. The excluded values only matter about what's on the bottom. So we're trying to figure out what's going to make this bottom into 0. Well, what is the opposite of plus 7? That's going to be negative 7. So b cannot equal negative 7, and there's your excluded value. Again, we don't care about the top. When we're talking about excluded values, we're only talking about the numbers in the denominator. So if we look here at this one, we have a denominator, but this denominator is not simplified yet. We don't have it as multiplication. We can't use that zero product property. So we need to factor this first, and in order to factor this, we're going to need our little diamond. That's going to have negative 12 on top and negative 1 on the bottom. The numbers that would work would be negative 4 and positive 3. So this factors into a minus 4 and a plus 3. Cross that out. Now, for excluded values, we're looking only at this bottom, so we're not worried about the top. And we're looking for the opposite of what these are. So we're setting them equal to 0 and solving them, but we don't need to show all that anymore. The opposite of -4 is going to be +4, so A cannot equal +4. A can also not equal, well, the opposite of +3 right here is going to be -3. So those are our excluded values. We happen to have 2 excluded values in this problem. You can have 1, 2, 7, it just depends on the problem. And the only part we care about when we talk about excluded values is the denominator. Now, to simplify, you have a little bit more to go through this process with. To simplify, you're going to have to go through and you're going to have to break these down. Now, to do this, again, we're not talking about excluded values, we're just simplifying, then we'll put the two together. We actually have done problems like example 3 before. We start by drawing a new fraction bar. We look at the numbers first and simplify those. 4 goes into 4 one time, 4 goes into 32 8 times, so we put that 8 on top. We don't need to put the 1 on the bottom unless there's nothing else there. The next thing we do is look at our variables. We look for where the highest exponent is. Since x has a higher exponent on the top, we will leave it up at the top. And 5 minus an exponent of the understood 1 right here is going to leave you an exponent of 4. For the y's, the bigger exponent is on the 1 on the bottom, so we put it on the bottom. And 7 minus 2 is going to leave us y to the 5th. That would be the simplified form of that problem. Now that isn't a monomial over a monomial, and we have done those before. Now we're going to do one that has a quadratic over a quadratic. Now we've factored them before, but not necessarily over top of each other where we had to simplify things out. So let's remember this process. To factor this, because you can't simplify things when there's pluses or minuses here, it has to be multiplication. To factor this, you're going to need to set up your little diamond. 14 here, -9 here. Remember, if it's positive on top and negative on the bottom, both of them are going to need to be negative, and the two numbers that would work would be -2 and -7. This would factor into x minus 2 and x minus 7. Cross that out. Do the same thing on the bottom. That's going to have -35 on the top, -2 on the bottom. That's going to work with numbers -7 and +5. So it factors into x minus 7 and x plus 5. Cross that out. Now to simplify, now that we have multiplication, these are multiplied by each other, we can cross out entire terms, and it has to be the entire term. So what do they have in common? They have this x minus 7 in common that we can cancel out. Now what that leaves us is the x minus 2 on the top and the x plus 5 on the bottom. And we don't need parentheses because it's not multiplied by anything else here at this point. So from there, the next thing we're going to do is combine those two concepts. Let's go there.